Hi everybody, solving paper 4, version 1, June 2019. First question. A rocket is stationary on the launch pad at time t equals 0. Rocket engines are switched on and exhaust gases are ejected from nozzles of engines. The rocket accelerates upwards. Figure shows acceleration of rocket varies between t equals 0 and t equals t final. Define acceleration, rate of change of velocity, sketch a graph to show how speed of rocket varies between t equals 0 and t equals t final, as the acceleration time graph has two portions. First portion, acceleration increases with time, so speed time graph should be a graph curve with increasing slope, and second portion acceleration is constant as time increases, so speed time graph is a straight line with constant slope. Some time later, rocket is far from Earth. Effect of Earth's gravity on rocket is insignificant. This line means there is no external force. As the rocket accelerates, momentum increases. State principle of conservation of momentum. Total momentum is conserved when no external force is applied. Explain how principle of conservation of momentum applies to accelerating rocket and exhaust gases. Increase in gas momentum equal to increase in rocket momentum, but in opposite direction. Here is the rocket. Here is the direction of acceleration and increase in momentum. Exhausted gas is fired backward. Here is the increase in its momentum. So rocket accelerates upward and increase in momentum is upward, and exhausted gases accelerate downward and the increase in momentum is downward. So although the two increases are equal, to maintain conservation of momentum, their direction should be opposite to have a total change of 0. Increase in gas momentum equal and in negative sign to increase in rocket momentum. So there is no net increase and there is no net change in momentum in the no external force condition. So conservation of momentum is conserved. Figure shows a sign that accident over a road. Mass of sign is given. Calculate weight of sign. It is mass times acceleration due to gravity. So it is 3.4 times 10 to power 4 Newton. Weight of sign acts at horizontal distance of from center of post support, and it produces a turning effect about point B. Here is point B. Here is the weight of the sign. Here is the post to which the sign is attached or hanged, and the center of the post from which the distance, horizontal distance, is measured to weight, and the point B at the base of the post. This is the point that the question needs to be the pivot, and the distance of this point from center of post is 1.3. Calculate momentum about B due to weight of sign. So momentum about B is the value of weight times the perpendicular distance from B to W. This distance is 1.8 sub minus 1.3, so it is 0.5. So momentum will be the width that we have just calculated times 0.5 meter equal 1.7 times 10 to the power 4 Newton meter. A concrete block is positioned on the other side of post with its center of mass at a horizontal distance of 70 centimeter from center of post. So here is the concrete block, and here is the center of post, and the distance is 0.7 to make it like all distance in meter. State what is meant by center of mass, point at which all mass of object can be located. Weight of concrete block produces a moment about B that exactly cancels moment by weight W. Weight W is the weight of sign. Calculate weight of concrete block. So moment of concrete block about B is in direction different from the direction of the moment of weight W, and its value should, the value of moment of weight of sign should equal to moment of weight of concrete, because we need the whole thing to be balanced or to be in equilibrium, and in equilibrium net moment equals 0. So to have both of them equal, we should have 3.4 times 10 to power 4, which is the weight of sign, times zero point 0.5. All of this we have just calculated to be 1.7 times 10 to power 5, power 4. We need this to equal weight of concrete block times distance, perpendicular distance from center of mass or weight of concrete block to point B, which is 0.7 meter plus 1.3 meter, so it is 2 meter. Okay, so the result will be 8.5 times 10 to power 3. Okay, yes. Concrete block is removed, sign and support both to rotate about point B in clockwise direction. State and explain what happens to moment about B due to weight of sign as it rotates. We have to imagine the situation. Here is the post, here is the sign, and here is the base with point B here, and weight of sign here. So the perpendicular distance, or this horizontal distance, will change as the sign and the post uh, folds away. Here is the weight, here is the point B, and here is the horizontal distance. It is clear that it increases. So perpendicular distance increases, and moment, moment increase, not momentum, moment increase. A cube of side 0.4, 0.04, 0.04 is floating in a container of liquid. Figure shows that surface of liquid is 0.028 meter above level of bottom face of the cube. Pressure of air above cube exerts a force on top surface of a cube. The valve is closed. Explain in terms of air molecule how force due to pressure of air is produced. Air molecules collide with top of the cube, and as this air molecule collide, there is a change in momentum per collision, and this change in momentum per collision over time gives the force. Density of liquid in container is 1500 kilogram per meter cube. Calculate pressure due to liquid at depth of 0.028 meter. We know the relation B equals rho GH. Rho is 1500 G10 H 0.028. So the answer would be 420 Pascal. And force on bottom face of cube caused by pressure due to liquid. We found the pressure, so we should multiply it by area because pressure equals force over area. So force will be this pressure that we found times area. Area is 0.04 squared or 0.04 times 0.04 because it is a cube. So the area of the bottom face is an area of a square. Okay, so we have 0.4 squared. The answer would be 0.672. The valve is opened. Here is the valve. It was closed, then it is opened, and the liquid is pumped into container. Surface of liquid rises a distance 0.034. So as we open the valve, pump liquid, liquid makes the liquid here rise a distance of 0.034 meter. Cube remains floating a liquid with its bottom face 0.028 meter below surface of liquid. Okay, so as the liquid rises this distance, we have our cube still has a distance, its bottom face has a distance 0.028 from the new level of the liquid. Calculate work done on cube by the force. As we have the bottom of the cube at same level as before with respect to the liquid surface, so we have the same force that the liquid applies on the bottom of the cube, which we calculated here. Okay, and to find the work done, we should multiply this force by a distance. The distance is the distance that the liquid moved the cube up, which is this distance. Okay, so we have a fixed value of force, but we have a distance that the liquid or which produces the force has moved. Okay, so work done will be 0.672 times 0.034, and the answer would be 0.23 joule. Okay. Okay. There is 0. Suggests one reason why this is not an efficient method of lifting up the cube, because there is an energy loss in overcoming friction between liquid and walls of pipe and walls of container. Liquid to go up, it makes some friction with these walls beside it, the liquids that exists before we open the valve, also has been lifted by opening the valve. Okay, so the energy of pump that is used to push the liquid lifted both the liquid and the cube, and we wanted to only lift the cube. Okay, so there is some energy loss that goes for lifting the liquid around the cube. Okay, beside, as we said, the friction. Gas of mass 0.23 gram trapped in cylinder by piston. Gas is at atmospheric pressure. Shows piston held in position by a catch. Volume of trapped air is given. Electrical heater is used to increase temperature of trapped gas by 550 degrees Celsius. Specific heat capacity 0.72 joule per gram degree centigrade. It is favorable to be in gram because we have the mass of gas in gram, and it should ask us about heat. Calculate energy required to increase temperature by this 550 degrees Celsius. Q equals MC delta T 0.23 times 0.72 times 550. Answer would be 91 joule. And the power of heater is 2.4 watt. Calculate how long it takes for heater to supply energy. B equals Q over T or T over T, E over T. So T equals Q, which is 91 over B, which is 2.4. The answer would be 38 seconds. In practice, it takes much longer to increase the temperature by 550. Suggest one reason, always heat loss to surrounding. When temperature of gas increase by 550, pressure is 2.9 times 10 to the power 5 Pascal. The catch is then released, allowing the piston to move. As the piston moves, temperature of gas remains constant. State and explain what happens to piston. Temperature of gas remains constant means that we will apply oils low as there is change in pressure and volume. So we should keep this in mind. It will certainly ask about it. But first he asks about state and explain what happens to piston. It moves to right, of course, because as the gas heated here and the catch was removed, the expanded gas will push the piston to right, and we can see that this expansion has been done by a force on a piston. You can mention also how in molecular uh, point of view this happened by the usual ideas that we always use, that molecules by increasing temperature gain kinetic energy and make more collision, so make more change in momentum, and this change in momentum per time means force. Or you can just write that it was an expansion because of a force applied by gas on piston. determine volume of gas when piston stop moving. So as I have said, we will certainly use Boyd's law, and we should know which is V1 and V1. The piston begins to move when the pressure inside was 2.9 Pascal and the volume was, I think it was written here, yes, 1.9 times 10 to power minus 4. Okay, here is the volume per cube. After expansion, temperature was constant and the piston in new position was at atmospheric pressure, and we need V2. Okay, so 2.9 times 10 to power 5 times 1.9 times 10 to power minus 4 equals atmospheric pressure is 1.2 times 10 to power 5 times V2. Here's V2 would equal, okay, 5.5 times 10 to power minus 4 meter cube. Okay, liquids and gases are two sets of matter in both boiling and evaporation. Liquid changes into gas state, way in which boiling differ from evaporation. Both state, any of the differences that you memorize. Boiling only at boiling point, evaporation at any temperature. Boiling has bubbles, evaporation hasn't bubbles. You can say also that boiling occurs at any point in liquid, or evaporation from surface only, and any other differences. Before injecting a patient, the doctor wipes a small amount of volatile liquid on the skin. Explain how this cools the patient. Liquid molecules gains kinetic energy from skin, become more energetic. Surface molecules in the wipe escapes and reduce total kinetic energy of all molecules of wipe, so temperature decreases because kinetic energy of molecules proportionate to temperature. So as kinetic energy decreases, means that temperature decreases. Gases can be compressed, but liquid incompressible. While in terms of molecules, intermolecular forces are not weak in liquid, so it is, it is not easily overcome. Intermolecular spacing are not large, so it is not easy to bring the molecule more closer to each other. Green light of frequency 5.7 times 10 to the power 14 hertz is traveling in air at a speed of light in air or vacuum. Light incident on surface of transparent solid, and the figure shows wavefront and the direction of travel. Light travels more slowly in transparent solid, except in terms of wavefront. While light changes direction as it enters solid. You may draw on figure 6.1. So we knew that wavefront in solid will delay than in air, and this delay means that there is a change in the angle of the wavefront in solid than in liquid, and as the direction of wavefront is perpendicular to the wavefront, it will have a new direction here. Okay, let us say that here is a normal and here is a change in the ray. If there isn't a solid medium, it should continues at the same direction, but because of the delay, the ray changed the direction towards the normal, and this new direction is perpendicular to wave front, so this wave front should also delay, and the reason is written. Refractive index of transparent solid is 1.3. Light incident on surface of solid at angle of incidence 67. Calculate angle of refraction in solid. So we have an refractive index equal to sine I, angle of incidence, over sine R, angle of refraction. So sine R, or simply R, equals sine minus 1 sine I over N. So we have 67 over 1.3, close the parentheses, okay, equals 45 degrees. Determine wavelength of green light in transparent solid. Again, N is equal to lambda air over lambda medium, because as you know, N is speed of light in vacuum or air over speed in medium, and any speed is frequency times lambda. Frequency is the same in both mediums because it is the same source, so lambda will differ, lambda from lambda medium, or we can say that n equals lambda over lambda medium, so 1.3 equals, we need lambda in air, and to find it we have only the frequency, so we can use that lambda air equals C air as 3 times over the frequency, something times 10 to the power 14, I is 5.7, 5.7 times 10 to the power 14, so lambda air would equal 3 over 5.7 equals 0.53 times it, and minus 13 10 to the power minus 6, which is 530 times 10 to the power minus 9 meter, or 530 nanometer. So this 530 nanometer over lambda m gives lambda m to be equal for 8 nanometer, or you can use this value and apply it in the equation and find the final result in something times 10 to the power minus 6. You uh, um, you are not obliged to use the nanometer unit, but I use it as it is familiar to use in dealing with visible light. Don't bother yourself, use the sample from you for you. Figure shows circuit diagram that include component X, state name of X, the symbol is symbol of thermistor. Electromotive force of battery E is E, switch is closed, potential difference across 30 ohm is V30, cross 20 ohm is V20, cross X is Vx. State and equations that relates Vx to V30. They are both connected in parallel, so V30 is equal to Vx. E and V20. E is EMF of the battery, and V20 E should equal to V20 plus Vx or V30 because they are equal. So E equals V20 plus Vx. EMF battery is 6 and resistance component X is 15. Calculate total resistance of circuit as resistance of component X is 15 and it is connected in parallel to 30. So combined these two resistors will give a resistance of 1 over 15 plus 1 over 30. This is 1 over R combined, or R combined equal 30 plus 15 over 30 times, sorry, 30 times 15 over 30 plus 15. It gives 10. 10 is only the total resistance of these resistors, so it should be added to 20 because they are connected in series. So 10 plus 20 equals 30 and unit is ohm. Meter reading, meter is connected here, so we can say that 6 volt, which is the total volt over total resistance, which is 30, equals 1 over 5 or 0.2 ampere. Don't forget this was obtained by Ohm's law. V equals I times R. Temperature of component X increases. We know that as temperature of thermistor increases, resistance decreases. So it is used in fire circuits. When temperature increase, its resistance decrease. So current in circuit increase, and alarm circuit increase, and the alarm is turned on. State and explain what happens to a meter reading as temperature of component X increase. We will say that resistance of X will decrease and the total resistance of circuit will decrease and current will increase. So then turn the handle of an EC generator and coil rotates. There is AC voltage output between the terminals. Explain why rotating coil produces an output. To main idea that as coil rotates, rate of magnetic field line cut by the coil is obtained, and this causes EMF. Induces EMF. Word induce here is a keyword that you should mention. You notice that in the question only output alternating voltage output. There is no mention for induction, so you must mention it in answer. State position of rotating coil when alternating output voltage is maximum value. It is maximum certainly when the coil is horizontal or in 0, 180 and 360 degrees. Let's explain why maximum output occurs at this position, because field lines cut are maximum. Lamp and open switch are connected in series to output terminal of AC generator. Switch is closed, the lamp lights up. Student has to apply greater force on handle. Explain why. Because induced current in coil is in direction that opposes magnetic field that causes it. Exactly as the coiled coil, when we approach a magnet, okay, field lines of magnet are cut by the coil, so and current is formed, and induced current is formed in the coil, and its direction is in the way that makes a magnetic field of north pole here, south pole here, north pole here, to repel the magnet or oppose the magnet that causes the current and the induced current and induced magnetic field at the first place. So it is the same for the coil in generator, as the magnetic field here causes the coil to have an induced current. This induced current is formed in a way to oppose this magnetic field, the magnetic field of the magnet. Okay, this opposition means that it needs energy, okay, or it needs work to overcome this opposition or to overcome this repulsion. Exactly here we were more than once asked why we should push the magnet to maintain a reading on voltmeter or ammeter, okay, because this opposition needs a force to overcome it, okay. Make the energy and you will understand what is written here. And second reason is energy is lost in lamp and more work is needed, as this energy is converted to light energy, okay. That's electrical energy converted to light energy. Figure shows a beam of alpha particles moving towards thin sheet of golden vacuum. As for the experiment, detector in region surrounding thin gold sheet detect alpha particle and determine number of particles that travel in various directions. State and explain what can be deduced from following. Majority of alpha particle pass through gold sheet undeflected. This means that most of atom is empty because particles have no collision in their path to deflect. Small number of particles deflected because it means first that small volume in atom contains positive charge. Particles pass nearby are deflected. Very small number of alpha particles are deflected through a very large angle and return back the way they came. Mass of atom is concentrated in nucleus. Probability to collide with nucleus is low, and you can add that atoms, a very small number, very small number of nuclei that collide has a great impact in changing its direction because mass of mass is concentrated in nucleus. Okay, A beam that consists of both alpha particle and beta particle is passed through a region of space where there is a magnetic field perpendicular to direction of beam. State ways in which the deflection of alpha particle differ from that of beta particle. First thing, an easy thing is roots deflect in opposite direction. And second thing is the magnitude of deflection or curvature of deflection, curvature or curve of deflection is greater for beta than alpha because alpha is more massive, so force applied on it will makes it uh, has less acceleration or less change in direction than beta, which has the lower mass, so has a greater acceleration and greater change in direction or greater curvature or deflection. Okay, this is all. Thank you all.